So I'm gonna share my screen. So today we're gonna do the second lab, which is the vector. And I hope you already submitted your first lab report. So I'll be grading them like after this evening or tomorrow. Please do submit your lab report for the first lab. If you have any questions, anyone has any questions so far?
About the lab report?
In general, everything, lab report or the class, anything.
Just on today's lab, but I don't know if that's what you meant yet.
Sorry, what?
I do have questions, but on the lab for today,
Okay,
but I can wait.
okay. So we can start. So we can then, I guess we can start the second lab and you can ask your questions um, during the lab session. Okay. Sorry, I don't know your name. Let's see.
It was Julio.
Julio. Oh, Julio. Thank you. Okay. So when you start this, and basically uh, this is the vector. I'm sure you already go through the vector chapter, and vector is very different from um, other quantities, which is like scalar. Scalar, you only has one magnitude. You wouldn't say there's a, like let's say the distance is 3 kilometers long. You wouldn't think about, oh, from west to east or from north to south. So vector is actually the vectors are very similar to scalars, but a vector also comes with the direction. So when we say something, we say direction, we will say like due north, or we indicate the direction. That's the only difference between scalars and vectors. So you can see here, for example, vector B. Vector B is a draw from the tail to head. And this one, because the head indicate the direction, and this part indicate the magnitude. So basically you take the absolute value of the vector, you will get the scalar. So in a sense, it's identical, but vector has direction, always comes direction. If there's no direction for a vector, then it's not called the vector. So since if we want to introduce the mathematics about vector, if we want to do the multiply, when we want to do the add and minus, and then when we try to add two vectors together, we have to really look into the vector, because the vector can be divided by the x-axis and y-axis. So, so when a vector, so any vector, you can calculate its horizontal component by the original vector times cos theta is the angle that the vector from the horizontal line. And so the vertical component AY is calculated by A times cosine theta. So basically you can see here, this is the x-axis and this is y-axis. And when you calculate the component of xy of vector A, then you normally have these two equations to calculate. So when you do, let's say you have another vector here, b, and you want to add them together, it's normally you can divide the b vector to the a bx and by. So you can just simply add each other on the same direction. Let's say if you add them together, you should calculate the ax plus bx. This is the total x, the resultant. So here, so when you do this, when you do the math, here's the equation you have to apply to your math, to your calculation. So basically, when we add two vectors together, then it's called a resultant. Okay, let me show you. So this is the online simulator. Okay. So let's say I have vector A and I want to explore 2D. So I have a vector A and a vector B. So if I want to add them together, so if you click here sum, this will be automatically calculated for the sum A and B. And then if you say, let me see. Sorry, I may turn off my video because I'm very allergic. I keep touching my nose. So this is actually a vector A and a vector B, and you can say that this is 6 and 8 are the X and Y directions components, right? So when you add them together, you could add like AX plus BY, and then you have like a total RX, and then AY plus BY. So you add them together, it's R Y. And then you use the equation which is given here. Say R resultant equal to X axis, the distance from X axis and the square, and then you add the Y axis square and take a square root. Then you get the absolute value of R, and then you have to indicate the direction. Remember I said any vector, it has to, a vector can exist only if he has direction and the magnitude. So this is the equation you calculate. So basically the lab today is pretty simple. So the first one, they ask you to explore the 1D. So basically 1D is very simple because it only has one dimension. So you can have a sum. The sum will be these two added together. But when you add up two vectors together, you put the one tail connected to the other vectors. You use one vector's head connected to the other vector's tail. So this connected together. And you can also say, you click here, the boxes here, you can check the value. So you can 5, the 5 is 10. And in the 1D direction, because all the vectors will be horizontal vectors, so the angle will be 0. So if we add another one, so it's 15, and you can drag this longer. And this is horizontal, and you also play around with vertical. Vertical is like still the same. You can just play around. So there's no requirements for 1D and 2D. So we will start our lab in the lab session here. And okay, same as 2D. Yeah, here is the eraser. You can erase them. And okay, so let's see what we have here. Okay, so now we can see two screens now. Still the 2D is very, so you just basically get familiar how to use this tool, because, okay, you can also move the sum away. So let's say if we want to calculate two vectors together, then you can add these two together, and then you just try to adjust anything. So there's a value, there's the angle, you can see the angle as well. So far, any questions?
Yes, for the lab report, do you want anything for part 1 and part 2 since it's just like playing around? No.
No, you don't need to do anything for part 1, 2. It's just like you get to know yourself. I think for the lab report, you just need to include the table. And pretty much the procedures can be, you don't have to write too much because it's very clear. So when I mentioned you have to write some procedures is when you have, let's say when I try to calculate something, let's say here calculated R, absolute value of R. So you want to show your procedure, oh, how you get this. You just don't give me a number like maybe it's 20. You don't give me a number, then you give me like a square root of a square plus b square equal to 20. So this is the procedure I would expect. So here you don't have to repeat it, just like type everything because this is not like much value. I mean, you can follow these procedures, but you don't have to like list all of them.
Thank you.
Okay. Any other questions so far? I guess this lab may be very easy. Yeah, I just or maybe I make it too a little bit fast because yesterday I just took this class. So yeah, okay. So for the lab, part 3, so you can just start your lab report from part 3. So it's pretty much the same, and you can see. So before we start, we have to introduce another concept, which is equilibrium. Equilibrium. Let's say this is we have to make a comparison between resultant and equilibrium. When we see a resultant, that means two vectors added together. Or you can say, you can say these two vectors added together. One is vertical, one is horizontal. And then you add them together. So from the beginning, from the tail of one vector pointing to the other vector's head, this is the resultant. For example, I'll give you an example here. This is one vector, and I get one more. Let's see. So these two vectors are not like it's not like it's all like random. It's not like totally vertical, totally vertical, horizontal. So if you add these two together, you can click a sum. It'll always be so you can double check as long as you make the vectors they connected to each other from the tail to head, then you can always say the sum will always matches from the tail to the head. So this is a sum. This is how we calculate resultant. So resultant is this, and then what is equilibrium? Equilibrium is at some extent, equilibrium is identical to the resultant, but it has the opposite direction. So let's put a value here. Okay, so you can see all the values, right? So if I wanna, so this dark blue is the resultant. If I want to say, get an equilibrium, what should I do? I just say, okay, the dark blue is 17, and maybe I put the angles here as well. So I just put here. So this like totally, I have to make sure this angle from the dark blue to the orange is 180. 180. Wait a minute. I think maybe it does not. Okay, so this one, so I have to make sure it's 140 because this one measures the angle from the horizontal line. That's why I feel it's weird. So now, I guess I try to.
Is there a way to like type in the theta up top
Right.
to 140? Probably not.
I don't think so. Yeah, but this is you can see this one is 139.8. This is 40.2. So add up together is 180. So this orange one is equilibrium of the resultant. So you can basically you can take it from the name. It's equilibrium. That means it must be balanced everything, right? So it's like a same. So they have the same magnitude. So which both are 17 unit, and the angles should be 180 difference, 180 degrees difference. So this is what an equilibrium is. Okay, let's start. We can start the lab together. So basically, we draw two vectors and calculate the resultant and equilibrium, and then put all the values into the table. So then that'll be the first part of the lab. So let's say they have some requirements. Let's say the first vector has to be from 5 to 10. Okay, it's so messy. I just so the sum, I can put the sum in aside. So this vector 1 value, I needed the value. So 10, so from 5 unit to 10 unit. I can use 10, then I have another one, which is, okay, so the angle, I also need the angle. Angle has to be 10 to 70, so this one is fine. So another one, vector 2, had to be 10 to 20. So a little bit longer, or just drag, you drag the head. I don't think you can drag it too, no. You drag the head, then you just extend the magnitude of the vector. Just make the vector bigger. And then the theta would be 100 to 220. So you have to be 100. Okay, you just draw two of them, like these two. So the dark blue always measure the sum of the light blue vectors. So this basically measures the sum of these two, the resultant of these two. So okay, before I go, like I think I should let you know how you fill these lines, right? So basically you can click this one. You see there's I with a slash, that means you cannot see the components. But if you click this, you can see the components. And then let's see the vector 1. Then you have the sum, the absolute value, which is 10. The angle, also 36.9. And V1x is 8. V1y is 6. So this is how you collect all the information from vector 1. Same as the vector 2. So you will, this one will be the absolute value of vector 2. And this is x, v2x, this is v2y, this is the angle. So you just put the information on the two columns. And then you have a resultant. Resultant is how you calculate, so there are two ways. One is you can calculate, one is observed. Observed one, just observe from here, because this one is already calculated for you, right? So you can, the observed R is 13.3. You just put the number here. The angle is 103, and the angle put here, Rx and Ry, you just put it here. So this is what you observe from the board, from this drawing board, you can observe. But how do we calculate them? The way we calculate is by using the equation here. Here. So it's a c squared equal to a squared plus b squared. So we have to measure, then we maybe use the orange one. So like, as I said, when we try to add the two vectors together, we have to make them connect to each other. And then, so this is vector 1, vector 2, you make the head of vector 1 connect to the tail of vector 2. So this is connected. And then you just measure, this is the orange one, to measure the sum of these two. So basically this is what you measure. See, this is automatically calculated. The dark blue is automatically calculated for you. So you can use the orange to measure these two vectors. And then you put so the absolute value, let me see. I guess you can also try to use, okay, when you calculate, okay, when you calculate this, I think the way you calculate is by using the equation, which is like you add x v1x plus v2x. This is the total rx, right? And the v1y plus v2y. Okay, let me write down something here. So Rx equal to V1x plus V2x. Ry equal to V1y plus V2y. And R, R absolute value, which is the magnitude, equal to square root. Okay, let me put it here. Equal to R x squared plus ry squared. So v1x and v1y you can get from like v1x, v1y, and v2x, v2y you can get from the vector 2, and then you can get the rx and ry, and you put it here, and then you will see you can calculate the r and the angle here. How you calculate the angle? The angle you. So the angle is using tangent. So let's say this angle from here to here is theta. So we say theta equal to our tangent theta. I don't know how to type theta. So tangent theta is tangent theta equal to y over x. So let's say, for example, so this, I'll give you another example here. So this one, this angle, let's say call it the theta. Theta is y over x. So you can search, okay, let's say arctangent theta. Let me see. So here is 8 divided by 8. So how much is it? It's 0.75, right? So 6 over 8. It's 3 over 4 is 0.75. Okay. 0.75. It's okay, so you can just Google. It's 36.9. 36.9. So you know how I calculated the theta, the angle, just by using, yeah. So y over x, then you search tangent. So equilibrium is basically the opposite of the resultant. This is already the resultant they calculate for you. You can use this one to mimic to show the exact. Okay, Okay, just too much, I cannot see. So this 103. This one should be 77, right? I mean, absolute angle is 77. And you have to make sure that the lengths should be equal each other, 13.3. 13.3. Yeah. So this one. So this is a equilibrant. So basically, let's say this is 13.3. This one should be 13.3. Let me write some at the same time. Just give me a second. I'll be right back. Okay, I'm back. Sorry. So then let's see where we left. Okay, I wanna use this to tell you. Let's see this one. The text. Let's say this one is 13.3, and this one equilibrium should also be 13.3. And the angle, if the angle for your resultant is 103, the angle for your equilibrant should be 180 difference. So you can use this number, your angle to divide to minus 180 or plus 180. So we minus 180 is minus 77, right? Minus 77. And then the r-axis, you can see here, the r-axis, oh, I cannot. If you move on the other side, basically the rx is the minus 3, then ex will be positive 3. If ry is positive 13, then the ey will be negative 13. So they always balance out, always be opposite. So you can just play around on this board and try to verify your answers. And then another question is they ask you if the calculated resultant is different from the observed. So basically, this is basically pure math. This is what you observed from this dark blue sum vector. And you can tell me what's the difference. Sometimes they should be identical, but like what we learned from the last lecture, so there are always some errors you cannot avoid. So it could be when you read, it's just some errors cannot be avoided. It really depends on the person who do the measurements. Okay. So yeah, this is for lab for part 3. And then another one is a real application in life when you use vectors. So any questions so far for this one, for the part 3?
How do we calculate the magnitude again of like V1 and V2? I understand why we got like V1x.
Oh, Wait, which one?
Like if we look at vector v1 and that top part, the magnitude or I guess the absolute value of v1 equals,
Mm.
what do we do to solve that one?
How you get this one? This two, like the
Not that one, not the resultant, but oh, is v1 x, but
okay.
just v
Let's try to
v1
calculate.
itself.
Oh,
If you look at like the table one under vector one, it's the
mm.
first one.
Yeah, the first one, the absolute value.
Yeah.
So
Oh, thank you, Talik.
okay, yeah, I can draw something. So the absolute value is so we see v1 equal to square root sq square root at, right? Square root, no. Okay, so it's v1x square plus v2x, oh sorry, v1y squared. So this is, okay, I think, let me look at the chat. Oh yeah, so I think Talike. Sorry,
Yeah, Talik wrote it too.
Talike. Oh yeah. So you have it. So does it make sense?
Yes, thank you.
Okay. So if there's no more question, then we can check the second part. I'll clean everything here. And let me see how to remove this input wizard. Okay, so the second part is to apply this vectors in the real life. So you can see here a pilot is flying her flight at the speed of 210 kilometer per hour due north. And then, okay, so my habit is when I read any math problem or physics problem, I just draw on the side. So let's see here, let's see the blue represent, okay, let me, so let's say this one is her speed. So we want to use 1 unit to represent the 10 kilometers per hour, right? So this one should be 21. Okay, let's start from here to 21. So this is her speed. She's flying due north. And then there's a strong wind which is 80 kilometers per hour. You wanna have like a 80, so we have to have 8 unit. I guess this is 7, this is 8. 8 unit strong wind blowing from west to east. So basically this is the current situation now. She's flying, she tried to fly in, on this direction, but she, but there's a strong wind. So the sum, the total resultant of her speed will be due from here to here, right? And then see, what did they ask? So they want you, sorry. So they want you determine the resultant direction and the speed of her aircraft. So you can add value, and you will see this is the sum, right? So you just indicate under the angles. So you indicate the resultant and the angle for this question, for question 3. And given the direction, so question 4, given the direction theta in which she should point her aircraft nose in order to remain on course to her destination. That means even this is the resultant because of wind, that she could not remain on her course. She should make her pilot remain on course, which to figure out ways that to make the resultant due north, like 90 degrees, right? So how are we gonna do that? So we try to say, because this is the speed. If we don't change the speed, let me move everything to the center. Okay, this is, okay. So let's say how I move. I try to adjust the direction and to the more west side, more west. So to balance the wind, right? So you can see the resultant is kind of close to vertical and close. Okay, now it's closer. I also have to remain the speed as 21, but I don't think I can do that. Because it's just because the, see, if I maximum is, yeah, I think 20.6 is more closer. So then you have this wind, add up together, the sum will be vertical. And then you take a screenshot of this picture when you try to adjust the speed of the pilot to make the flight remain on course to her destination. So this is what you're gonna show me. This is a screenshot, but I guess they also ask you, okay, they give the direction theta, which should point her aircraft nose in order to remain on course. So that means that you give me the direction of this one. And so basically, I don't want you read from this graph because this is not 21 exactly. I want you to do the math yourself. So when so basically, let me think. This should be, so this one you have to determine. So basically, what we do here is to use the x component to balance with the wind, and then you only has the y-axis. I think this one should be. So basically, what you do the math here, let me write it on equations on the screen. Text. So this one, you want to figure out the y, right? Because this is 21, this is 8 for sure. This is y is 8 for sure because the wind is 8. We want to balance the wind. So that's why this is 8 too. So we want to figure out what is y. Y equal to square root of, so 21 square minus 8 square. So you know where this one is from, right? Okay, so basically, resultant equal to, okay, let me put this way, equal to x square plus y square. And then a resultant here is 21 and the x is 8. So you can calculate y. And after you calculate y and you want to figure out the angle, which is what they ask you. So theta, I really don't know, maybe we can use this one, theta equal to, okay, equal to arc tangent of y over x, which is, okay, okay, almost which equals to y over, so which is equal to y. So the y you calculate here divided by 8. So then you can have a theta. You can Google what's the theta value. So you put it here. Does it make sense? Are you guys
Yes.
following me? Okay. Yeah. So question 5 is consider when she landed her aircraft, she has to slow down. And when she slowed down, that means her speed is no longer 21 anymore. So it will be, okay, I have to turn it off. The speed. Okay, so the speed will slow down. That means, so then she will not be able to remain on course anymore because the speed is decreasing, right? So how will this affect her ability to stay on course for north south aligned runway? So basically it will just make it everything slightly pointing to the east, right? Pointing to the east, yes. So this is the consequence. And what corrective action can she take to compensate and ensure she remains on course? So what she can do is to adjust the directions even more west. You see, when it's decreasing, now it's 15.3, but she still remains on course by having a bigger angle, right? So if I want to decrease, if she wants to decrease again, so then if you want the resultant remain on course, you would just change her direction even west. Basically, you want to maintain the x component always be 8 to balance the wind.
How do we know how slow we want her to go? Or is this what we're guessing?
So basically this one, you can answer how this affect her ability is she will fly to west, to east, a little bit towards east. No, not towards east. Like, how do you describe the direction? Like when she, like
Yeah, if she's like going north, like if she's heading forward, the wind's gonna make her go east.
yes, so she will have a slightly direction fly to east, right? So you don't have to specify how much it will be changed because it just asks you to describe. You can describe what you see. And then what the corrective action she can take is to just say she had to adjust her direction to more west in order to remain on the course. Right? So any questions? So basically you just finished this. For question 5, for question 4, you do the math. For question 5, you just use descriptive word to say to explain what you can see here. Then yeah, that's it. That's for all for the lab.
Thank you.
Before you go, I think I have to take attendance. So where is my attendance? Summer. Okay. Let me see. So I don't want to record attendance taking, so let me stop recording. Okay, stop.